All right, here's example 2.7 from PreCalculus OpenStax. In this example, I guess you could argue that we are kind of combining topics from 2.1 and 2.2 because 2.2 gets more into the graphs of linear functions. And this example is asking you to write the equation of the function given the graph. Although the way the book solves it, you don't really rely on any 2.2 knowledge, but I'll kind of talk about both as I work through it. So we want the equation of the linear function. It doesn't explicitly tell you to write this in slope-intercept form, but that's kind of the standard way you express a line. So eventually, really what you'll want your answer to look like is something like this. Except instead of m and b in here, you'll want numbers in place of m and b. The number in place of m will be the slope, and the number in place of b will be the y-intercept. So to get it in this form, you have a couple different options. What your book does is it first figures out the slope of the line, and then it puts the line in point-slope form. And that's totally fine. You can do that. It turns out for this specific problem, you could figure out the answer without ever using point-slope form. You can go straight to slope-intercept form. Because if you look at the graph here, one of the points that's on the graph, this point right here, when the x-coordinate equals 0, the y-coordinate equals 2, this is the y-intercept. And the y-intercept is b in mx plus b. So just from this point right here, we can deduce that b is equal to positive 2. So we're kind of halfway there. If we could just figure out m, we'd be done. And to figure out m, there's a couple options in how you can figure it out. M is the slope. So if you think about this kind of more intuitively, you say, well, the slope is the rise divided by the run. So you find any 2 points that are on the graph. So like you could use this point and this point right here. But the downside to using this point right here is it's a little bit hard to tell what the x-coordinate is right here. So I'd probably use, maybe this dot in blue right here. And it looks like this dot in red up here falls at integer coordinates, just meaning it's pretty clear that this has an x-coordinate of 2 and a y-coordinate of 8. And so now you got some options. You can either go to your formula and say the slope is the change in the y-coordinates over the change in the x-coordinates and get your answer that way. Or you could just kind of talk your way through it. Like as I was getting at, the slope is rise over run. So from this point to get to this point, how far do you go up? Well, you go up by 2, 4, 6. It looks like you go up by 6. Okay, how far do you go to the right? Go to the right by 2. So therefore the slope is 6 divided by 2. 6 divided by 2 is 3. So the slope is just 3. You can just kind of look at this thing and tell that m is equal to 3. Or if you're someone that likes formulas, you say, okay, fine, I took this point right here, and I don't know, maybe we'll make this one x1, y1, and this x2 and y2. So y2 would be the coordinate of this red dot, the y-coordinate of this red dot, which is 8, the height of that red dot, minus y1 would be the y-coordinate of this blue dot, the height of this blue dot, which is 2. And you divide that by the x-coordinate of this red dot, which is 2, minus the x-coordinate of this blue dot, which is 0. And so you get 6 divided by 2, which is that same answer of 3 that we got down here by thinking of it more as rise over run. At this point, you have everything that you need. You can jump straight to the answer. You can say f of x equals mx plus b, except m I know to be equal to 3, and b I know to be equal to 2. So while there's nothing wrong with the way your book solved the problem below, there's another way you can kind of think of things. So I'll call that good here.